Java polymorphism. Polymorphism in Java allows an object to take on multiple forms, enabling methods to perform different actions depending on the object they operate on. This concept is implemented through two mechanisms: method overloading, where multiple methods with the same name but different parameters are defined, and method overriding, where a subclass provides a specific implementation of a method already defined in its superclass. Polymorphism is an object-oriented programming (OOP) concept that allows a single method or function to perform various operations depending on the object it is interacting with. This means that one method name can represent different behaviors based on the type or class of the object on which it is invoked. Method overloading is a mechanism in Java that allows multiple methods to have the same name but different parameters. In Java, method overloading can be achieved in two ways: by changing the number of arguments or by altering the data types of the arguments. However, method overloading cannot be accomplished solely by changing the return type of the method. In the calculator class, method overloading is demonstrated by defining two add methods with different numbers of arguments. The first add method takes two integer parameters and prints their sum, while the second add method takes three integer parameters and prints their sum. In the main method, an instance of calculator is created, and both versions of the add method are called with different numbers of arguments to illustrate method overloading in action. In Java, method overloading allows changing the data type of arguments to create multiple methods with the same name but different parameter types. In the given example, the calculator class has two overloaded add methods, one that takes two int arguments and another that takes two double arguments. Each method computes the sum and prints it. In the main method, an instance of calculator is created, and both add methods are called with int and double values, respectively. Method overriding is a mechanism in Java that allows a subclass to provide its implementation of a method that is already provided by its superclass. Method signature, name, return type, and parameters of the overridden method must be the same as that of the superclass method. In Java, method overriding allows a subclass to provide a specific implementation for a method already defined in its superclass. In the example, a vehicle class is created with a run method that prints vehicle is running. A bike class extends vehicle and overrides the run method to print bike is running. In the test class main method, instances of vehicle and bike are created, and their respective run methods are called, demonstrating polymorphism where the method in the subclass bike overrides the method in the superclass vehicle. Above code is written as three Java program named vehicle, Java, bike, Java and test class, Java with main class on it. In a scenario where the bank class offers functionality to retrieve the rate of interest, the interest rates differ between banks. For instance, RAG Bank may offer an 8% interest rate, ENBD could provide 7%, and CBD might offer 9%. The shown code demonstrates method overriding in Java through a parent class bank and its child classes. The bank class has a method getRateOfInterest, returning a default interest rate of 10. Each child class RAC, ENBD, and CBD overrides this method to return different interest rates, 8, 7, and 9, respectively. In the test class main method, instances of each class are created, and their respective interest rates are printed, illustrating how method overriding allows child classes to provide specific implementations for inherited methods. The given Java code demonstrates method overriding in object-oriented programming. It defines two classes, parent and child, where child inherits from parent. Both classes have a show method with different implementations. The parent class's show method prints parent display, while the child class's show method prints child display. In the test class, the main method creates instances of parent and child and calls their respective show methods. The output will be parent display when calling P, show from parent, and child display when calling C, show from child. The given Java code defines three classes, grandparent, parent, and child, where each class contains a show method that prints a specific message. The parent class extends grandparent, and the child class extends parent, thus forming a simple class inheritance hierarchy. Each show method overrides the one in its superclass. In the test class, objects of grandparent, parent, and child are created, and their respective show methods are called. Method overloading occurs within the same class, where multiple methods share the same name but have different signatures, i.e., different parameter types or numbers. In contrast, method overriding happens when a method in a subclass redefines a method from its superclass, maintaining the same method signature, allowing the subclass to provide a specific implementation while retaining the original method's name and parameters. Super keyword in Java is a reference variable used to refer to the immediate parent class object. When an instance of a subclass is created, an instance of the parent class is implicitly created and can be referred to using super. It serves various purposes, including referring to the parent class, calling the parent class constructor, and accessing parent class variables and methods. This helps in reusing the functionalities of the parent class while extending or modifying behavior in the subclass. Super keyword is used to access the member variable num from the parent class parent, which has been hidden by a variable with the same name in the subclass child. The child class inherits from the parent class, and both classes define a num variable, with parent's num set to 10 and child's num set to 20. Super can be used to access methods of the parent class from the child class. The Java code demonstrates method overriding and inheritance. The parent class has a method 1 that prints a message. The child class extends parent, overrides method 1, and introduces a new method 2 that calls the parent's method 1 before printing its own message. The test class runs the code to show how methods from both classes are invoked and how super can be used to access the parent class's method. If you make any variable as final, you cannot change the value of final variable, it will be constant. If you make any method as final, you cannot override it. If you make any class as final, you cannot extend it. A final class cannot be extended, meaning no other class can inherit from it, such as with the math class. A final variable is a constant whose value cannot be altered after assignment, like final static double pi equals 3.14159. Furthermore, a final method cannot be overridden by subclasses, ensuring its implementation remains consistent across the inheritance hierarchy. Java code results in a compile time error because the Honda class attempts to override the final run method from the bike class, which is not allowed. Java code defines a final class bike that cannot be extended, and a Honda class attempting to extend bike can override its run method. Since bike is declared as final, this results in a compile time error because final classes cannot be subclassed. Consequently, the code fails to compile and does not produce any output. Question 1 Part A involves implementing the circle class, which serves as the parent class. It should include a method readRadius for inputting a positive radius from the user, a method calculateAreaPerimeter to compute the circle's area and perimeter, and a method displayAreaPerimeter to print these values. Additionally, the class should feature a default constructor circle that sets the radius to 0, and a parameterized constructor circle, doubleRad, that initializes the radius to a specified value. Cylinder class, as a subclass, includes a readLength method for inputting and validating the length and radius of the cylinder, ensuring the length is greater than 0. It also has a calculateVolume method to compute the cylinder's volume using the formula volume equals area asterisk length, and a displayVolume method to print the calculated volume. The class features a default constructor, cylinder, which initializes the radius to 5, the volume to 0, and the length to 15. Part C involves implementing a test class with a main method to test both circle and cylinder classes. It includes creating an instance of the circle class, calculating and displaying its area and perimeter, followed by creating an instance of the cylinder class, calculating and displaying its volume. Question 1 Part A Solution. Implement the circle class. Detailed Java code given here. Question 1 Part B Solution. Implement the cylinder class subclass to circle. Detailed Java code given here. Question 1 Part C Solution. Implement the test class with main method. Detailed Java code with results are given here. Question 2 Part A involves implementing a cube class with methods and variables to manage and calculate properties of a cube. The class should include variables for the length, surface area, and volume of the cube. It should have a setLength int x method to set the length of the cube, a getSurfaceArea method to calculate the surface area, and a getVolume method to compute the volume. In Part B, implement a cuboid class as a subclass of cube. This class should inherit the properties and methods from cube and override the getArea and getVolume methods, displaying the message overridden method x, where x is the method name. Additionally, declare variables for width and height, and provide methods to set these dimensions, setWidth, int y, and setHeight, int z. Include methods to calculate and return the surface area, getSurfaceArea, and volume, getVolume, of the cuboid. Part C involves implementing the test class with a main method to test both the cube and cuboid classes. The tasks include creating an instance of the cube class, setting its length, and displaying both its surface area and volume. Similarly, an instance of the cuboid class should be created, with its length, width, and height set, and then its surface area and volume should be displayed. Question 2 Part A solution. Implement the cube class detailed Java code given here. Question 2 Part B solution. Implement the cuboid subclass to cube, detailed Java code given here. Question 2 Part C solution. Implement the test class with main method, detailed Java code with results are given here. Thank you for watching.